Hello, everyone. We're going to start in a minute, so please be patient. Okay, perfect. Hello, everybody. Welcome to the next AppNox webinar. So this is our third AppNox webinar. Our first AppNox webinar was into mobile application security testing, where we showed how we can use free and open source tools to perform manual application security testing on mobile application. That was our first webinar. We got a huge response and we decided to have this webinar at least once a quarter. I hope my audio is clear. I think Ravi is saying that the audio is still echoing. All right. Our second webinar was into API security. So we kind of, okay, perfect. I'm getting feedback that it is clear. If the audio is echoing at your side, then probably you may need to wear a headphone or a earphone. I think that will clear the audio issue. As I was saying, our second webinar was into API security, where we kind of, again, showcased open source tools and techniques of how you can use these tools to figure out API security issues in API URLs. In our third webinar, what we have decided was if we can address about the code obfuscation part. So for the code obfuscation part, we actually partnered up with Verimetrics. So from Verimetrics, we have Neil. So Neil is going to join me in this webinar, and he's going to explain, about code obfuscation, how is it done, what are the different techniques used in code obfuscation, and he's also going to show some live demos along with it. So we have Neil from Verimetrics, and if you guys have any questions, please use the Q&A box and you can type in your question. Whoever is watching this webinar in social media channels such as Facebook or Twitter, you can post your questions there itself in the comment or in the Twitter. In Twitter, you can put the hashtag AppNox webinar. We'll try to answer your questions while we are going through the presentation during this webinar. So that is a little bit about this. I'm gonna intro myself a little bit. So I'm Shubho Haldar from AppNox. So I'm the co-founder and CISO over here. And at AppNox, what we do is we figure out security issues in mobile applications in an automated fashion. And we help companies, fix these security issues on their side. We also have Neil. Neil, do you want to go ahead and introduce yourself?
Yes, hello everyone. I'm Neil Meekie. I'm one of the product managers at Verimetrics, and I look after everything we bring under the code protection heading. So that includes our tools for obfuscation and wider protection of applications.
Great. So what we're going to do is we will start this webinar. Neil, you can go ahead and show us everyone what what is obfuscation and how obfuscation helps, as the first step towards the security, securing your mobile applications.
Okay, so let's dive into it. So as we heard in the introduction, previous AppNox webinars, we've looked at how to pen test and some of the vulnerabilities that occur in mobile applications. Within this webinar, over the next 55 minutes or so, we will look at one of the technologies in fairly detailed, one of these technologies that helps to protect the applications, helps to protect your code. And that technology is called obfuscation. And if you look at a dictionary definition of obfuscation, it's about making something obscure, unclear, unintelligible. So when it comes to code obfuscation, what we're looking to do is to make our code obscure, unclear, and unintelligible to the attackers, to the people that are trying to reverse engineer our applications and our software. Of course, why should we care about that? Making code obscure, unclear, and unintelligible. That's really the opposite of good coding. From day one as a software developer, you're taught to make things clear, logical, easy to understand, easy to maintain. Obfuscating code is really the opposite of that. It's making things hard to maintain, hard to read, hard to understand. But by doing that, we also make them hard to reverse engineer, hard to attack, so that when we come to pen test, when we come to put our code into the wild, it's safe and it's secure. So we'll look into kind of why we should care about doing the opposite of what we're trained from day one. So just to give an overview of what we're going to talk about over the next hour. So we've started the introductions already, but we'll go through and we'll do a quick introduction of who's Verimatrix, why have we been asked today to come and talk to you. And we'll also look into the problem statement, kind of do a brief overview of what are the risks, what's the problem we're trying to solve with obfuscation. It's always important to understand the problem before you start looking for solutions. We'll then dive into obfuscation, we'll dive into what it means and kind of some of the techniques that are used, and then we'll look at solutions for applying the obfuscation, how we do it, and very briefly at the end we'll look at going further. We'll look at some other techniques we can use to augment the obfuscation. In terms of who Verimatrix are, I just want to give a brief introduction. We're a security company. We specialize in securing different solutions and providing technologies to secure solutions, be that video content, be it software, be it mobile payments. We work in a number of different industries to stream and protect, to secure and protect data and software in the wild, and then the application and usage of that software. We're a global company. Our headquarters is in the south of France, but in reality, we're spread around the world with staff in 17 offices and customers in 120 countries. So kind of well spread around the world. We try to do things slightly differently. So when it comes to security, we don't just follow the trends. We don't just do what everyone else is doing. We look at new ways of doing security, more friendly ways of deploying secure solutions. So we look at kind of, for example, when the rest of the world thought that cable TV boxes needed a smart card in them to authenticate the user, we went out and proved that it could be done with a software solution. When the rest of the world was trying to deploy hardware-based payment solutions using secure elements, we've gone and shown that it's more practical and more cost-effective to do that with software. And we continue to do that. And kind of obfuscation is one part of how we can drive security in new ways and new directions. You may not have heard of us, but there's a good chance you've actually used our technology. You've been protected by what we do. So whether that's streaming a video to your smartphone, whether it's making a mobile payment or transacting with your mobile banking app, or whether that's just buying your favorite cafe latte, there's a high probability that you've used our solutions because we're deeply embedded in lots of industries and lots of technologies. In terms of who's speaking, you've already heard from Shobo in the introduction. I also briefly introduced myself at the start. So I'm the product manager at Verimatrix for code protection. We also have Keir's story on the chat channel. So Keir's a very experienced field engineer. He knows this stuff inside out and did a lot of help in prepping me for this webinar. So if there's any questions or comments that come up as we're talking, as we're explaining this, please put them into the chat window, and Keir is there to help answer them. But that's enough for the introductions. Let's dive into what we're actually trying to solve, what we're trying to do. So a very good introduction was the first AppNox webinar on pen testing mobile applications. It beautifully showed how soft a mobile application is, how easy it is to get into it and to then start to extract secrets from it. The analogy I often use as an application is an open book, and the attackers are trying to read that book. And you saw through that webinar, and the link's there if anyone wants to go and have a look at it. If you've not seen it, I highly recommend you do. But kind of at a very high level, what we learned through that webinar was how easy it was to take an application from one of the app stores, and our example on the slides, Google Play, but kind of there's plenty of other app stores and other platforms where this is equally applicable to. But it's very easy to take the application package from the app store and not install it where it's meant to be installed, not put it on the phone, but put it on something like a laptop, desktop computer, where we can start to analyze it, start to look at it. And in the Android world, the SDK that's provided by Google gives you all the tools to be able to go and get the software on your laptop, get that APK onto your laptop. And then there's free tools online that allow you to unpack that APK and start to look at the code, look at the assets that's within it. And from there, we can start to investigate, we can start to read the code. And that reading is called static analysis. And the attacker uses this static analysis to build up an understanding of how the code's operating, how it's behaving. They maybe learn some secrets, extract some data from the application as well. But that basic understanding allows them to go on and start their attack. So if we look at a real application, this is a banking application from a UK bank. I won't tell you which one. But we very quickly, going through that process, managed to get into the code. And this is a snippet of the code here. And that bank didn't want, for risk reasons, didn't want the application to be running on a rooted or a phone with malware on it. You can understand why that would be. But by reading the code, we can very quickly find where they've built that check into their code. And then it's fairly straightforward and fairly simple from an attacker to go on from that basic understanding. They find something interesting, and then to remove that, to get the code running where it shouldn't be, or to extract a secret from it. So very quickly we go from an APK sitting on the App Store to actually into the code finding something interesting. And that's what we learned in more detail from the earlier webinar. But why do attackers want to do this? What are they trying to get out of it? The simple fact is, kind of not only is a mobile app interesting from a technical kind of, well, let's go and see what we can find point of view, it's very informative to an attacker. Nearly all mobile applications these days interact with a larger ecosystem. They're not a standalone piece of software. They talk to backend servers, they talk to backend services. And the mobile app contains all the information required to talk to that system. And we'll look at that in a bit more detail in a minute. The mobile application is also the interface to your services, to your product that your user, and through that interface they provide personal information, and that is their trust point, that is their access point. And if they don't trust that interface, then they're not going to trust the rest of the service. But the mobile application is, as the interface point, is processing all your users' personal information. That personal information is very valuable to the user, and increasingly we see legislation around the world, such as GDPR in Europe, the privacy legislation in California, and the same spreading around the globe, that puts an onus on the service providers to protect that personal information. If the mobile app's the weak point, then that's a good opportunity for the personal information to leak out, and then you lose the trust from your users, but you also then have to deal with the regulators as well about why the personal information has been leaked. The other danger, which I'm highlighting here, is software, particularly mobile apps, are self-documenting. If you're reasonably skilled at reading codes, reverse engineering, then an application tells you everything you want to know about it. It tells you all the bugs that are there, all the vulnerabilities. And the simple fact is, kind of the average is for every 1,000 lines of code to have between 15 and 50 bugs within it. And that means on an average smartphone app, there's over 1,500 errors sitting there waiting to be exploited. And okay, a lot of those errors are minor, they'll never come up in practice. Those that do are probably more functional than security, but it only takes 2 or 3 security-related bugs to be in the software for an attacker to be able to exploit them. And you see that kind of repeatedly with kind of some of the examples we've seen from WhatsApp, some of the examples we see from other applications as well, that an attacker will find a bug within the software and then work out how to remotely trigger that bug to create a security exploit. And they do that, they find the bug, they start all this process by reverse engineering the application to find the vulnerabilities. So it's important to protect the applications. I mentioned earlier that the mobile app is the trusted, well, has all the information to access backend services. And this would be covered when you're looking at API security, but you give the mobile application trusted access to the backend, because you open up an API, you open up a gap through your security perimeter to allow the mobile application to do what it has to do on the back end. And if an attacker can get into the mobile application, understand how to gain that trusted access through reverse engineering the application, then they can start to not just attack the application, but also attack the backend services. So it's important to build API security, not open up more than you have to. But it's also important to remember to secure the endpoint, to secure what's talking in, so that an attacker can't learn to reverse engineer and learn how to access the back end. And the final point on the risks is one which I think we consider a lot, but then we tend to forget when we're going to deploy. You spend a lot of time and effort building your application, and you recoup that effort through usage of your mobile application, either monetizing it or through engagement, or kind of however you want to drive business through your mobile application. And that kind of recoup, that effort goes into building IP. So you don't want an attacker to lift the IP and then use it for their own. And what we see is, in extreme cases, an attacker will just republish the app under a different name. And what struck me recently is we've spent a lot of time going to software development conferences, talking to the guys that are coding Android applications, iOS applications, and just discussing with them What do they see? What's the risk? And one of the things that struck me was the number of them that told me, oh yeah, I developed a game and I saw it reappear on another app store with a different title. Or I saw my library was lifted and used elsewhere without my permission. And kind of these developers found that very soul destroying. They found that very hard to deal with because all their hard work was then being stolen and used to benefit someone else. So it's important to protect your IP, whether it's just to protect what you're doing, your brand, the effort you put in. And maybe you've got sensitive algorithms, sensitive IP that you want to keep safe as well. And kind of that IP is part of your business model. So you need to keep that safe as well. And obfuscation, as we start to look into that, is part of the solution here. It's part of how we protect the applications, how we stop this reverse engineering. Now, if you remember our simple attack path at the start, attackers are trying to open the book to read the code, to read what's happening so they can learn and extract useful information from it. And obfuscation is a way of hiding that useful information. You know, if it's a way of making it less intelligible, making it harder for an attacker to read. If we continue the book analogy, so if attackers trying to read the book, really what obfuscation is doing is taking that book, making some of the text really small, some of it really large, putting it in an obscure font, then shredding it all just for good measure. None of the information is lost. It's all still there. It's all still kind of functionally the same, but it becomes very, very hard to read, very hard to get into and work out what's going on. And that's what obfuscation is doing for us. It's taking kind of logical, well-designed code and making it difficult to understand, difficult to read. And there's many different techniques used in obfuscation, and kind of as we start to dive into them, you'll see how they build up to create a strong, well-protected application. It's not just kind of one technique, but lots of techniques come together. There's a cliche that security is applied in layers, but it's very true. As you build up the layers, you get much better protection. It's important though with those layers to make sure that they complement each other, so the sum of the parts becomes more than just the kind of individual components. There's a multiplying effect as you put each component together. And that's how you get efficient, sensible obfuscation. And we've got to remember that it's not just the human mind that's going to be understanding your code, trying to read your code. Kind of attackers use tools like IDA Pro, Ghidra to get in and start to help them understand how the software is behaving, how it's working. So there's tools out there that are designed to start to put the obfuscated code back together, to present it in a way that's more meaningful to an attacker. So good obfuscation is not just about confusing the human attacker, but also confusing the tools the attacker is using. And it's also important, and we'll talk about it more as we go through this, but it's also important that the confusion that we're creating in our code is balanced with the needs of the business. We've always got to remember when we're looking at security, considering security, what is the wider business? What's the wider use case of this software? We've got to be practical when it comes to this, and we'll come through some of that as we're going through the slides in the presentation. So let's dive in to some of the techniques. Let's start to get technical. Let's start to look at actually what does an obfuscator do, or what can an obfuscator do to your code. So the type of obfuscation most people are familiar with is a type of obfuscation called symbol obfuscation. And kind of what we find when we start diving into the makeup of software, particularly languages like Java, is there's often meaningful names that become part of the flow. So when a Java class wants to, or Java method wants to call another method, you build that method name into the software so that the application knows where it needs to call. And good coding practice means that these names are meaningful, they're well structured, and by being meaningful and well structured, they start to reveal the functionality of the code. In our highlighted example, we can see someone's created a package in their application called the SSL socket factory. So we know this package from its meaningful name is dealing with the secure networking. And as an attacker, that becomes interesting to us. So what symbol obfuscation is doing, it's replacing these meaningful names with something that isn't meaningful to an attacker. It strips out the information from the name. It leaves the code functionally the same, but it's removing meaningful information. There's also a nice side effect here that we can go from long, meaningful names to very short names. So we get a slight advantage of optimizing the code, making it smaller. That's probably the most common form of obfuscation that developers are familiar with. If we continue on our thread and move away from just kind of the superficial side of the code, so the packages, the kind of top level, and actually start to look into the code itself. Code often has constant values, literal values that are embedded throughout it. And these variables, may be meaningless, but they may also reveal clues to the operations of the code. So, for example, if you are building up a login message to your server, you're building a JSON structure, you may have tags within that structure that are username and password. Somewhere within your code, you have to define those tags. And if an attacker can find that tag definition, that's a literal value within your code, as a constant within your code that says password, suddenly we've found something interesting. Suddenly we've found a bit of code that we know is operating on the user's password. It's a simple example, but it's a very real example that you frequently see. Equally, maybe you're accessing backend services and you've got API keys that authenticate your software to the backend service. These typically become embedded somewhere within your application. They have to be. Again, if an attacker can get these out, they can then use them for their own uses. And that's a story we hear quite frequently when we're talking to customers and we're talking to developers, that someone's gone into their application and lifted the API key out that they defined in their code. So string encryption, to some extent, does what it says on the tin. String encryption takes these literal values that are within your code and within your compiled application, and it hides them, it makes them encrypted so they can't be read statically. You can't just scan the code and find them. They're not there anymore, they're encrypted. They get decrypted at runtime, but statically reading them, these values are no longer there. So it's creating barriers for the attacker. Not all literals are strings. We do have numerical values as well, like integers, like booleans within our code as well. And these can also be useful for an attacker. These can also give clues to what an algorithm's doing, to what code's doing. And there's different techniques to hide these literals from the code. Just like the string literals, we can also use encryption to hide these values. Or we can use expressions that are very difficult to deduce the value. So kind of our example code has a few values, like kind of jumping out to me now is 4 and 3. But we could use complicated algorithms or complicated expressions that resolve to be 4 and 3, but from an attacker's point of view, when they're reading the code, when they're just statically analyzing it, working out what these expressions resolve to becomes very difficult. So we add another layer of complexity to the attacker trying to work out what the code's doing, making it harder to see what the values are, what the code's meant to be doing. So we've taken out the strings, we've taken out the other values now as well. if we move on to just obscuring values in the code, the next class of obfuscation that we're going to look at is called control flow obfuscation. And what control flow obfuscation is doing is going from just obscuring parts of the code or removing information from the code, and it's then changing the flow of the code, actually scrambling, reordering the code. So it's hard to follow, hard to understand the logic that as a developer you put into the application. Our first example is inert code. This is sometimes called dead code or junk code insertion. And this is code that doesn't change the functionality of the software. It doesn't make it behave any differently. It doesn't really change the flow of the software, but it's putting in code that is there to distract the reverse engineer. It's a decoy. It's making things more confusing. It's giving them more code that they've got to work through and understand. So they're not just a nice logical path with, and all the code is functional, but we're actually putting in code which is a decoy. It's not functional. But as an attacker, you've got to work through it, because even with this code will execute, it will flow as if you watch the application stepping through, but it's not actually giving any real benefit to the end user. It's there as a decoy. And in my open book analogy, I said one way of obfuscating was to make the text really, really small in the book. And that's what we've done with our examples on the screen. So if you're struggling to read the text of the examples, it's because it's been obfuscated. So diving in further and looking to make the code more difficult to follow, making the paths of the code more obscure, we move on to a technique called conditioned code. And conditions code is when you create artificial branches within your code. So you use what's called an opaque predicate. And an opaque predicate is an expression that it's only possible to work out how it's going to compute to, what that value is going to resolve to at execution time, but it always resolves to the same value. So in effect, it's a constant, but when you're statically analyzing the code, it doesn't look like a constant. And so you use these opaque predicates to create artificial branches. So you've got an if-else statement in your code, but only one branch of that if-else statement is actually real code, is actually legitimate code that's going to execute. The other branch is inert code, is code that's there as a decoy. But for the attacker to work out how the application is going to behave, how it's going to operate in a real environment, they've got to reverse engineer this. It's adding more complexity to the process the attacker's got to go through. One of the most effective means we find for control flow obfuscation is called go-to insertion. And with go-to insertion, what you're doing is you're messing up the execution order. You're taking code which is logically laid out. So if you looked at the binary, you would be logically following the instructions one step after the other. Nice, neat, tidy code. Easy to follow, easy to understand the flow. And then by putting in go-tos, what you do is you make the code jump around apparently randomly to the attacker. So rather than nice, neat sequential steps through the binary, we now jump around different parts of the binary. So our function, which would be sequentially laid out and nice and neat, is no longer sequentially laid out. It's spread around, it's disjointed, it's in the wrong order. So when you start to look at it with some of the reverse engineering tools, it's all over the place. It's not nice and neat anymore. It's much more difficult to understand and to follow. And you can see just how much more complicated it gets by the fact that the example screenshot gets really, really small in terms of text. Another nice technique is flattening, and there's different forms of flattening you can do to code. Loop flattening is when you make loops, so for loops, while loops, more difficult to understand the flow. And in effect, with flattening, and we've got a small example on the left here, but you take what would be neat sequential branches within your code, a nice tight while loop that has a statement at the top, does what it needs to do, jumps back to the top to validate itself. If it's still true, we continue around the loop. If it's not true, we jump out. It's neat, it's tidy. When you flatten it, you take that nice, neat sequential code that's sitting kind of vertically in the stack, and you spread it all out so it all appears to look parallel when you visualize the code. So it goes from being neat and compact to spreading out very wide across the code. When you start to look at it, you start to visualize it, making it very hard for the attacker to work out what it's doing, to understand how it's behaving and how it's all fitting together. So when you're dealing with loop flattening, as I said, you're going after kind of loops within the code, for loops, while loops, do while loops. And then there's different ways of flattening them. You can turn them into a series of go-to expressions. So rather than having the loop there at all, you start to replace it with branches and go-tos and conditional checks. So the loop disappears. Or as you can see in the diagram, you can also do it with switch statements and other techniques as well. So you go from neat code, well compacted, well structured, to code that just spreads out and is difficult for an attacker to work through. You can do the same technique on if statements. So as with the loop flattening, the aim is to obscure the control flow, to obscure the hierarchy and the logic of the program by making that visualization of it kind of much harder, much more complicated, and very flat when you visualize it. And when you deal with if statement flattening, obviously you look for if statements, you look at branches within the code, and then you expand them out, you replace them with a nice if, then else, with go-tos, with label operations, and you make it much, much harder to follow that code, to understand what that code's doing. As well as flattening a loop, you can also unroll a loop, and to some extent they get slightly confused as techniques. So kind of unrolling, is that not flattening it? And vice versa, but they're actually different techniques used in different ways. So as we saw with the loop flattening, it's taking the loop and then spreading it out wide in a visualization, making all the code appear to sit at parallel at the same level in the call hierarchy. When you unroll a loop, in effect, what you do is you take the internals of the loop, so the code block that sits between the two braces, and you take those internals, and then you just copy them for every time the loop would iterate. So you remove the for, while, or the do statement, and you just make the code multiple copies. So if your loop is going to execute 6 times, then you copy the code 6 times. It's obviously a technique which is much more effective and easier to apply if you know the number of iterations at compile time, because then you know how many times you've got to copy the loop. But you take the statement and you spread it out, you expand it. And naively, if you just copy the same block of code 6 times, or however many iterations there are through your code, it's not that hard to pattern match and to say, actually, this is the same block of code repeated 6 times. Someone's just unrolled the loop. But what you're looking for when you're unrolling is to see how a loop evolves. So typically within a loop, there's values, there's variables that are used by the loop that evolve and change for each iteration. And when you actually analyze the code and look at the code, what you find is these evolutions are the same for every run of the loop, no matter what the input data is on the loop. These iterations are the same. So kind of while X may be 1 for the first iteration, X is 2 for the second iteration, X is 3 for the third iteration. If you actually look at the loop and look at how it's behaving, X is always 1 for the first iteration, it's always 2 for the second iteration, it's always 3 for the third iteration. So while they look like variables that are changing in your unrolled loop, actually in your rolled loop, in your unrolled loop, these become constants, and you can start to clean up your unrolled code by taking advantage of the fact that things that were previously variables become constants. And that means that each iteration of your loop isn't the same. It isn't the same each time. So you don't end up with the same block of code copied 6 times. You actually end up with different code for each of the 6 iterations. And this makes any pattern matching much hard. It makes it much harder for an attacker to identify that this was an unrolled loop. And of course, we're applying this with lots of other techniques. We're applying this with lots of other obfuscation that we've talked about previously. And as that goes through the code, it starts to kind of make it much harder to pattern match, to put things back together, because they all work together, they all add together. If you think, if we've got our unrolled loop 6 times, and then for each of those loops, we obfuscate it slightly differently, we use different techniques, we apply the techniques in slightly different ways, then each of those unrolled loops kind of becomes very different. It looks different, it's maybe got different inert code inserted into it. We've treated the if statements differently, we've hidden the literals within it using different techniques. So each block becomes very different, and the sum of the parts becomes much greater than the whole. So, and that's what's important when it comes to obfuscation. It's making sure that the techniques you're applying, they're not working in isolation, because that's expensive, but they're actually working together, and then you get good effect and good impact on your application. So before starting to apply obfuscation to your code, before starting to really delve into and picking a solution or applying a solution to your code, there's a few things that you should consider. The first is very simple. What are you actually trying to protect? What is the asset? What's important to you? And the asset often isn't something within the code directly. It's not maybe a security value that you've got hidden within the code, but it can be wider. You need to think about more holistically and think about the business and kind of what's important to your business that's encapsulated within that software. And once you've identified the assets, once you've identified what you need to keep safe, that allows you to select the obfuscation you want. It allows you to target it in the right way. If you don't start by thinking, what's the asset, then we're just trying to cover everything. We're going wide. Whereas if you know what the asset is, you can be much more targeted, and that gives a lot of benefit to what you're doing. And a simple example is, are you protecting source code or are you protecting a binary? So if you're protecting a binary, maybe you're publishing it to one of the app stores, then that's very different, a very different type of obfuscation than maybe you're distributing source code to a customer. And what you want your customer to do is compile that source code into their application, and then they'll distribute it. but you don't want the customer to be able to maintain the source code, to change the source code, or use it in any way different to how you intended them to use it. So in that case, you'll be obfuscating the source code to make it unmaintainable, unchangeable by your customer, which is a very different requirement when it comes to obfuscation than if you're protecting a binary which is going to end users. So it's important to consider these things, to consider what the asset is, what's important to your business, and what you actually want to achieve with the obfuscation. It's also important to consider balancing business needs and software needs with the security needs. And when we talk about cost here, we're not talking monetary cost, but we're talking about kind of the impact on the application footprint or its performance. We've seen, looking at the techniques and looking at some of the examples, that kind of obfuscation does come with a cost, and it's making code more complicated, and that makes it larger and potentially less performant. So you need to understand that. You need to understand what the wider business needs are of the software, and not just charge ahead and get kind of the maximum security possible on every single byte of the code, but to make sure that's balanced with the wider needs and the wider requirements of the development. And a good way of getting those balances, of making sure it meets the wider business needs, is to make sure that you have control over the techniques that are used and how they're applied. So you can target them, you can use them in the correct way, and that allows you to balance. So you get the best of both worlds. You get the best of security, but also the best of performance, or kind of whatever else you're trying to optimize for. So you need control. You need to be able to target kind of not just which parts of your software they're being applied to, but ultimately kind of control how the rate at which they're applied as well. So you can get the right balance. You can make sure you don't damage the business case for your software. Because ultimately, security needs to be practical. You need to be able to use it within your environment, and ultimately, you're selling a product and a service, and that needs to be appealing. It needs to be attractive to your customers, and security should support that. It shouldn't hinder that. So I would urge you to consider those questions before opting for any security solution. Kind of what's the wider impact on the business, and what are we actually protecting? What is the asset being protected? So let's delve into a couple of solutions. What's available for you to go and try today, to get out, work with your developers, work with your applications, and actually apply today. So the good news is there's open source options available. If you're developing for Android, then you have probably heard of ProGuard, or more recently R8. And these come as part of Android Studio. Google provides them with the tools to develop Android applications. They provide you with Obfuscator, which kind of historically has been ProGuard. They're currently rolling out R8 as a replacement to ProGuard. These tools describe themselves as being a generic optimizer for Java bytecode. And the reason they use that definition and they don't describe themselves as obfuscation is because they're really just doing simple obfuscation. If you remember our example at the start, they were taking long, meaningful names and shrinking them down to short 1 or 2 character names. So they're optimizing the code, they're making it smaller. Simple obfuscation on its own is not a massive barrier to an attacker. And that's why these tools are careful not to present themselves as being obfuscated, but to emphasize their optimization capabilities instead. But as I said, they're part of Android Studio. They're very easy to integrate into an Android application because they're part of the development tools. It's easy to turn on Android, to turn on ProGuard or turn on R8 from within Android Studio. And because of this, there's no monetary costs. There's very little development costs in terms of this. So there's no reason an Android app shouldn't ship without at least being symbol obfuscated with ProGuard or R8. And I would almost argue it's negligent not to be ProGuarding an application before publishing it to Google Play. And there's lots of documentation online on how to use it and how to configure it. So it's kind of Google is your friend here. Google will guide you on how to apply it. It's not an onerous task to at least apply symbol obfuscation to an Android application. And I would urge everyone to, if there's one takeaway from this webinar, is to make sure developers have turned on ProGuard. If we move over from Android to iOS, which for the interest of balance is important, the iOS tool, so Xcode, doesn't come with obfuscation out the box, but there is open source options available. So one to go and look for is called Obfuscator LLVM. It's on GitHub and it integrates with Xcode to provide some of the control flow obfuscation techniques that we've discussed today. It actually operates on the compiler's intermediate representation. So if you dive into how modern compilers operate, so Clang is the most common one for mobile development these days. But if you dive into how a modern compiler operates, it takes your source code, so C, C++, Objective-C in this case, and then it goes through a compiler front end, which generates an intermediate representation, which then gets passed to the compiler back end, which converts the intermediate representation down into the executable machine code, so the ARM code. And Obfuscator LLVM operates on that intermediate representation. So it's to some extent language neutral, provided the compiler supports the intermediate representation. As I say, kind of what Obfuscator LLVM is offering is some of the control flow obfuscation techniques we've talked about today, and it integrates with Xcode to try and make your life easier as a developer. There's one thing which is worth mentioning and worth highlighting for anyone developing kind of C-based languages. They're compiling down to native libraries, so .a's, .sos, or executable binaries. It's important to remember to always strip the binaries. So the compiler chains come with a tool called strip, and that removes metadata that's part of the compiled binary. So whether it's a library or whether it's a final application, there's metadata in there, which is designed to help with debugging. It's designed to help with understanding what the code's doing. Obviously, anything which helps understand what the code's doing is very, very useful to someone trying to attack or reverse engineer the code. So the strip tool, which is part of the compiler tool chain, is very useful because it takes this metadata out. It also reduces the size of your code because it's taking data away. So it's important from an optimization point of view as well. We do see when we are working with customers, when we're analyzing some of their applications, that quite often they forget this strip stage to kind of make sure they've removed erroneous or kind of useful to an attacker metadata. So I wanted to highlight that point, that the tool is there. Again, just like ProGuard in the Android world, I would make sure you're using it, make sure that you're cleaning up the binary before you distribute it out your organization. We also hear a lot about Google's safety net, and this is moving back to Android. And what safety net is offering developers is a way of attesting or checking that the Android device that the app is running on is a legitimate device. It's not got a modified firmware on it. It's not had someone change or corrupt the device. It's a legitimate, officially sanctioned Google Android device that is running as it should be. And it's a server-based solution, and it's there to help you as an app developer or help the app itself decide if the Android device is compromised or not. It's a category of checks that we class as environmental checks. I'll discuss that in a bit more detail in a few minutes. But it's not providing any obfuscation or any real protection to the code itself. What it's doing is allowing the code or the application to validate that it's running within a trusted environment, to run within an Android device that appears to be legitimate and hasn't been modified or compromised. So it's a useful tool, useful functionality from Google, but it's not obfuscation. It's not making the code any harder to reverse engineer. If you haven't obfuscated your code, then an attacker could find where your application is using and utilizing Google Safety Net, remove that from your code to then get it running somewhere that it shouldn't be. So it's another useful barrier, but it's not obfuscation. It doesn't provide the protections, the confusions that we've discussed earlier today. I want to go back to our simple attack path, because I want to highlight that kind of obfuscation is a very good barrier, but we need to make sure we're considering other things. We're looking at other areas as well. So kind of our simple attack path, the first thing the attacker was doing was trying to statically analyze the code. And we said that obfuscation helps create barriers, helps stop an attacker statically analyze the code. And if we go back to our symbol obfuscation example, so kind of when we looked at symbol obfuscation, this here was the example we used of a symbol obfuscated application. It's now time to let you into a little secret. That example, we didn't start with the source code. We actually started with an obfuscated application. This was a banking application that told us they were protected and obfuscated. And we actually started with the obfuscated code, and then using a free tool online, we were able to pattern match and put back the information that they thought they'd removed from the application. So when I showed you the code being obfuscated from the right to the left of this slide, actually, in reality, we started with the left and got back to the unobfuscated code that was able to give us the useful information. So what I'm highlighting here is simple obfuscation is not enough on its own. And this is just simple obfuscation, so it's important to apply other layers of obfuscation. It's important to look at how we can add control flow obfuscation, how we can actually dive into the methods, into the functions, and make them hard to follow, hard to understand. But there's some other techniques we can use as well. So as well as just applying obfuscation, we can stop the attacker getting other understandings. We can stop the attacker moving on from their static analysis to dynamic analysis. And dynamic analysis is when you observe the application running, you start to get into seeing it behave, seeing how it operates. So a good way of doing that is to use environmental checks. And we talked about the Google Safety Net service earlier. So if we make sure the software is running on a trusted device, someone's not attached a debugger to it, the phone's not rooted, they're not using a hooking framework to modify the code, then that creates more barriers. It starts to complement what we've done with the obfuscation. But if you remember an example right at the start, what's the attacker looking for? when they're statically analyzing it, they're looking for useful information. And if that useful information is how the environmental checks are performed or where they're executed from, then it becomes easy for the attacker to strip them out. So obfuscating the code, making it hard to find this data from it, is very useful. But what's also useful is to anchor all our security protections within the application. And it's a technology that we call anti-tamper. Other people call it integrity checking. But if you build your software and anti-tamper the software in a way that means it can't be changed, it can't be modified, it means that, yes, an attacker can try and remove the obfuscation. They can try and take your confusion, pull it back together, but they're not going to be able to execute it because the anti-tamper stops them. If they maybe find the environmental checks, they find where you're calling Google Safety Net from and how you're using it within your application, they can't remove it. It's part of your code. So, and the nice thing about environmental checks, the nice things about integrity checking, is the cost of these technologies in terms of performance, in terms of application footprint, is often a lot less than we see with obfuscation. So it very nicely complements obfuscation. It allows you to use obfuscation in a much more targeted, productive way, but actually allows it to be more effective at the same time. So we start to get the best of both worlds. We start to have kind of strong obfuscation, but kind of well-targeted, kind of highly performant code running on a trusted device, and it all stays together in a tightly bound bundle. So kind of, we've talked a lot about obfuscation. It's a very important barrier, but I just wanted to highlight that we can go further when protecting our applications, when protecting our code from reverse engineering, and looking at different techniques that aren't traditionally under the obfuscation category, but actually play very nicely with obfuscation to make sure it's properly bound into the application. Just to very quickly wrap up, if you found this interesting, if you'd like to play with some of the technologies we've discussed, whether it's the obfuscation technologies, whether it's the environmental checks or the anti-tamper type technologies, then there's the open source tools available that we've mentioned earlier, and there's others around as well that you can use. Kind of Verimatrix provides tools and technologies to implement these technologies as well. So we provide on-premise tools, but we also have a protection service called Protect My App that allows you very quickly, very easily to apply these protections into an application. It's available for you to try at protectmyapp.com. And as a thank you for listening to me for the last hour, we'll give you 30 days access to the service for free. Just use the discount code AppKnox20 and you can get on and log on to the site, upload an application and get it back protected. All you need is 5 minutes, the app, your work email address, and of course your AppKnox20 discount code. And before I say thank you and wrap up, I'd just leave you with one message, that if your application is valuable to you and your users, it's almost certainly valuable to the bad guys too. So with that, I will say thank you and hand back to Chapo.
Thank you. Thank you so much. So that was really an informative session. Guys, I have sent out a poll. You guys can go ahead and vote for the poll. Also the discount, thank you so much for, giving discounts to, all the people who have joined the webinar. If you guys have not get the coupon, we are going to send it post the webinar. We will be sending out an email blast to everyone who have joined. We also have the recording recorded. So we'll also share a link to the recording for your information if you need to go back and refer anything in the recording. Thank you so much, Neil, for the amazing presentation. I hope we did answer a lot of questions which you guys have asked. We'll also share the questions which you guys have asked post the webinar, just for your reference with everyone. I hope everyone liked this webinar. Uh, Thank you, everyone. Thank you, Neil, for the webinar. See you guys. Bye.
Thank you, everyone. Have a good day or a good evening, depending where you are in the world.